Hello. In this video, we are going to go over an example that asks us to graph a piecewise function. And then it also asks us a couple of questions about that piecewise function. So I'm going to do this in a slightly different way than I did in class the first time around, just to make it a little bit more clear what's going on here. G of x is made up of three different functions with three different domains. So I'm actually going to start by graphing these three different functions on three completely separate graphs. So our first function, right here on the top line, is y equals -4. I'll graph that in the first grid. Then our second function, I'll do that in green, is y equals -x² plus 3. I'm going to graph this on our second grid. And then the final one is y equals -2x plus 6. So we're just going to graph all three of these to see what they look like. Let's start with y equals -4. That is going to be a horizontal line that goes through the point y equals -4. So -4 on the y-axis is here. This line will have a slope of 0, so it'll just be a horizontal line going left to right through that point. So that's what this function looks like. The green one, the -x² plus 3, is going to be a parabola. And there are a couple of different ways we can graph this. One way is by using transformations. Our parent function x² looks like this. So we could think about an x² graph being flipped and shifted up 3. So that would flip it upside down, and that would make our graph go through the point 0, 3. So then it would go down like this. And then, hold on, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm just counting this out to make sure I get my points in the right spot. So this is what -x² plus 3 looks like. That's a wobbly line, but close enough. The other way you could graph this is you could actually just pick points and plug them in. So you could take, x equals -2 and figure out what y equals. In this case, it would be -1. You could plug in x equals -1 and get your y value. You could plug in x equals 0 and get your y value. So you can basically make a table of values to figure out where the different points on this graph would be. So that's an alternate way of graphing this function. Now let's look at our third grid. We have a function for a line, -2x plus 6, which is written in the form of mx plus b. So m, our slope, is -2, and b, our y-intercept, is +6. That would go through the point 0, 6, which is right here. And it would have a slope of -2, or -2 over 1. -2 over 1. So I'm going to do this a few more times just to plot some nice points here. And then we're going to draw our line. Okay, so far I haven't answered the question at all. Okay, this is just prep work. I'm just looking to see what these three different functions look like. But the important part of a piecewise function is that the various pieces of your function each have a specific domain. So our first function has the domain when x is less than or equal to -1. So I'm going to write that here. Well, x is -1 happens right here along this vertical line. The places represented by x is less than or equal to -1 are going to be from this line and to the left. Which basically means that when we're thinking about this red piece of our function, we're going to ignore everything to the right. So get rid of all of this, goodbye, and we're only focusing on this part of our line from here over. Now another really important piece of our domain to pay attention to is this symbol. If it's a less than or equal to symbol, that means that our red line's domain includes this point right here on our boundary. So we would give that a nice solid dot to indicate that that point is included on the boundary here. So moving on to the green grid, the second piece of our piecewise function, the domain of this part is for x between, I don't like the way they wrote this, I prefer to write them like this, x between -1 and +2, where -1 is not included, but +2 is included. So let's draw those lines on our graph. So -1 is here, and it should come as no surprise that that actually matches up with the boundary on this grid as well. And then +2 would be right here. So all we care about is the points where x is in between -1 and +2. So we're going to ignore all of this to the left and all of this to the right. And we're only looking at our green graph from here to here. I'm going to try to make it nice and bold so it's easy to see. Now let's look at our endpoints. For our green graph, -1 is not included in the domain. So we would get an open circle right here to indicate that this point is not included in the domain of this part of the piecewise function. But +2 is included in the domain, so we would get a nice solid dot here on the boundary line for +2. Now it's time for our blue line here. The domain of this piece of our piecewise function is x is greater than 2. So let's find our boundary. +2 would be right here. And again, no surprise, but this matches up with that boundary line as well. So where one boundary ends, usually another one begins. All right, so for this one, we care about the points where x is greater than 2, so that would be to the right. So we don't care about anything to the left. Now let's figure out our boundary point. So our domain is x is greater than 2, not greater than or equal to, just greater than. So here we get an open circle where this is not included in our domain. All right, so we did quite a bit of work here just to figure out what the three different pieces look like, but we haven't answered the question, which is graph this. We want to graph it all on the same graph. So I'm going to scroll down here and zoom out just a little bit so I can see all of these pieces. We're actually going to graph the whole function as a single graph. So we'll start with the piece of our piecewise function on the left there, the red piece. That looks like it starts at -1, -4, and it's a vertical line that goes left. Notice it has a solid dot on the boundary because that point is included in that domain. Next, we have just a piece of a parabola that starts at -1, 2 with an open circle. It goes through the point 0, 3, goes through the point 2, 1, and then it stops at 2, -1 with a solid circle. So that looks something like this. Close enough. And then the final part of our piecewise function looks like it starts at 2, 2 with an open circle, and then it has a slope of 2, so it kind of goes down to this point and then this point like this forever. So a couple of things I want to point out about the graph I just drew. First of all, don't forget arrows. If you have the left or the right hand side of your function goes on forever in one direction, don't forget to draw those arrows there. And then second, make sure that your pieces of your function line up. Notice that if we go back to the original function, my function should change domains at -1 and +2. So our graph should look like it has breaks, so to speak, at -1 and +2. And in fact, that's exactly what we have here in this example. Okay. For part B of this problem, we want to just evaluate a few different points. So this is as simple as looking at your graph. The problem is If you made a mistake in your graph on part A, then you're going to get part B wrong too. So there's an alternate way to solve part B, and I will do it both ways. So let's start with g of -3. Let's start just by looking at my graph. If I plug -3 in for x, that means we're here. The y value is -4. So you can look at your graph and find your y value. But if your graph is wrong, then your answer for this part would be wrong too. So you might want to double check yourself. And here's how you do that. When we're plugging in -3, we go up to our function and we have to figure out which of our 3 pieces to plug -3 into. So that's going to require looking at the domain. So if x is -3, does that make x less than or equal to -1, in between -1 and 2, or greater than +2? Well, it would be less than -1. If we're plugging in -3, that's less than -1, so we would plug it in to this function. And when you plug x in here, no matter what, you always get out -4, so that's how we got -4 as our answer. So let's do the next one. If we plug in x is 0, one way to do this would be to look at the graph. If we put in x is 0, our y value is +3. So that's our answer there. But again, if you don't trust yourself to draw a really good graph, you might want to double check yourself by going back up to the function. Now keep in mind we're plugging 0 in. If you're plugging 0 into this graph, 0 is in between -1 and 2, so we'll be plugging it into this part of the piecewise function. So when we plug 0 in, we get -0 squared plus 3, which is just 3. So we ended up with 3 as our answer. 2 more to do here. If we plug in +2, now this one's a little tricky. So if we plug in +2, we're here at this point. But it almost looks like we have 2 different options here. We've got -1, and we have this +2. The whole point of drawing your graph so that your circles are either opened or closed is to indicate to yourself which of these points is included in the graph. An open circle means it's not included, meaning it's not a solution. So we're looking for a closed circle here. So there's only one answer, and it's -1. Let's do the algebraic method now. So we're plugging in 2 for x. Let's figure out where we would plug it in. So if x is equal to 2, if we're plugging 2 in for x, then we're not going to plug it in here because this is for x is greater than 2. But if x is 2, then this isn't right. We're plugging it in here because x can be less than or equal to 2, and we're plugging in x is 2. So again, we're going to plug it into this function, so it'll be -2 squared plus 3, which is -4 plus 3, which gives us -1, which is exactly what we got. All right, last one of this type, we're looking for g of 4. So we're plugging 4 in for x, 1, 2, 3, 4. When we do that, our y value is -2. Pretty easy to see from the graph if your graph is correct. So now let's go back up to our function and plug this in algebraically. So we're putting in x is 4. So to decide which domain to put it into, we need to find a place where x can be 4. How about right here? 4 is greater than 2. That works just fine. So we're going to plug 4 into -2x plus 6, which will be -8 plus 6, simplifying down to -2. And indeed, we had -2 as our answer. So 2 different methods to find the information that's asking the same exact question. We've got one more thing we need to do for this problem, and that is find the range. So when I'm finding range, oddly enough, all I really look at is this y-axis right here. That's how I indicate my range. And let me show you what I mean. I'm looking for y values that are included in this graph. So look at your graph. You know, you've got pieces that kind of go in different directions. I like to just kind of take my eyes and start at the top of my graph. Do I have any y values up in this area where I'm drawing these question marks? No, none of these pieces, none of the three pieces are ever going to have y values up in that area. So this part is not included in my domain, or in my range, excuse me. The first place on my graph where I start to see y values is right here. I'm marking it in blue. This is the uppermost area of my range. Now I'm going to continue marking in blue any part along the y-axis where y values will be part of my function. So notice we do have y values along all of this part. There are y values here. There are y values going down forever. In fact, the part of our piecewise function that goes kind of down and to the right, that's going to keep going down forever. So I would keep coloring this blue line until I reach the bottom of the earth. So we're just going to put a line there to indicate that my range goes down forever. So this blue line represents my range. It will be everything from negative infinity all the way up until positive 3. Remember, you always write it from low to high, negative infinity all the way up to positive 3. And positive 3 is included in my range. Notice we even had 3 as an answer as a y value just a minute ago. So 3 is included in my range. We'll put a bracket here. They told us to write the range in interval notation, so I wrote it in this form. If they ask you to write it in set notation, it would just be the set of all y values such that y is less than or equal to positive 3. Close set. I do want to point something out. When people were doing range, they were forgetting that it was y values and they were putting x's here, so be careful of that. And then the other thing I want to point out that students were making mistakes on is you were writing it from 3 to negative infinity. That's backward. Don't do that. That's like pretending that you're born and you're 100 years old and then you just age backwards your whole life. We always count up, not down. So be careful about the order that you write those in. And there you go. I hope this helped. I know piecewise functions have been a point of difficulty for a lot of you, and so I tried to break this out and do it very slowly and very bit by bit. If you continue to have questions on this type of problem that I can help with, maybe come see me during my office hours from 12 to 3 on Wednesday, or you might even be able to shoot me an email in the evenings one night this week before the exam and pose your question that way. All right, good luck and happy studying.